So let's get started today with factoring trinomials a little more deeply, in which our lead coefficient, our a value, is not equal to 1. It's actually greater than 1. So as a quick reminder, when we factor trinomials, they need to be written in standard form. So don't forget that's ax squared plus bx plus c. More importantly, when we see our trinomials in standard form, our a, b, and c values must be integers. But more importantly, we want to make sure they're reduced by their GCF, by their greatest common factor. So if A, B, and C share a common factor, before we can go about factoring the trinomial further, we need to strip out that greatest common factor, factor it out separately. Okay, that's not going to be the case in these examples today. So let's get started. In the case of our first example, 3x squared plus 11x plus 8, I can clearly see that I am in standard form. I know my a value is 3, my b value is 11, my c value is 8. Now from here, we're going to change things up a little bit, because when we're factoring trinomials where a was equal to 1, all we cared about is that we multiplied to our c value, which is 8, while adding to our b value of 11. Now that we're introducing a value of a that's greater than 1, we have to change up specifically that product target. That product target, if you notice, is now going to be based on multiplying two numbers that result in whatever a times c is. So in this case, a times c, that's 3 times 8. So we're looking to get to a target of 24 here. We're looking to get to a target of 24 here. Okay. And our sum target is still our b value, is still 11. So wouldn't you know, when we look at the product of a times c, just conveniently, it happens to be the combination of numbers that multiply to 24 while adding to 11. You know, if our b value was 10, then we would have been looking at 6 and 4 instead of the 3 and 11. Okay, so our factor pair is 3 and 8. And these are going to become your coefficients for middle terms. And I'll explain what I mean in a moment. Okay, so, but these are the two numbers that we need to work with right here as we move on to filling in our box. So first thing we want to recognize is in this box, and by the way, you don't need to draw this fancy box. You're just going to basically do something like this, in which you have 4 corners. It's important for you to know that the upper right, the upper left always has to be filled with the lead coefficient of your original trinomial. So in this case, that's going to be 3x squared. The lower right has to always be filled with the constant of your original trinomial, so that's 8. From here, these remaining boxes are going to be filled with these two numbers that made up your factor pair, but acting as coefficients for the variable. So we don't just say 3, we have to say 3x. We don't say 8, we say 8x. I want you to think about this box as being the unsimplified result of foiling whatever our factored version of the trinomial is. So you can begin to see that if these were the two middle terms from foiling, these would be the results of your outside inside. And when you combine 8x and 3x, hey, check it out. There's your 11x right there. Okay, so now moving on, what we need to do is to treat these two rows as binomials, these two columns as binomials, and go back to using our skills for factoring monomials from these binomials to ultimately get to our final answer. So let's move along. So if I treat this as 3x squared, because that's a positive 3x, I think of that as plus 3x, then the monomial as the greatest common factor I can pull from that binomial is 3x. if I look at the bottom row as another binomial, 8x, and again, because it's positive 8, think of it as plus 8, the greatest monomial factor I can factor there is an 8. Now, if I go down in my two columns and treat these as binomials, 3x squared, again, if it's 8x, think of it as plus 8x, the greatest common monomial factor is simply x. And in 3x plus 8, you might be looking at that and say there's nothing. 3 and 8 don't share a common factor. There's no common x, but we need to factor something. So when all else fails, 1 is our common factor. So I have everything I need between these two values here and these two values here, because these become the pieces of my binomials. If I take these two numbers and fill in as one binomial, and I take these two terms and fill in as the terms of my other binomial, I have my answer. And if I were to quickly check by foiling, well, let's see, 3x times x should give me 3x squared. 3x times 1 is my outside term, should give me 3x. My inside term, 8 times x, should give me 8x. My last term, 8 times 1, should give me 8. When I combine these terms together, I'm back to 3x squared. There's my 11x. Hey, those were those two terms we filled in the box, plus 8. So I know I'm good to go. So my final answer, my final factored answer we've proven is right there.